At a secret base on the outskirts of a major city in eastern Ukraine, intelligence experts and technicians from Ukraine's military intelligence agency, HER, worked tirelessly for 4 weeks. Their target was Armavir Airfield, a key military facility located about 155 miles southeast of the Ukrainian border. This airfield not only trained pilots, but also served as a link in Russia's southern air defense network near the Crimea Peninsula. The base hosted tactical air units, including squadrons of Su-27 and Su-30 fighters, along with early warning radars and command posts, making it a top strategic target. The Su-27UB, a 2-seat training variant of the Su-27 fighter, was selected as the target due to its strategic and symbolic value. With a maximum takeoff weight of 73,855 pounds, twin AL-31F engines providing 27,560 pounds of thrust each, a top speed of Mach 2.35, and the ability to carry 13,228 pounds of weapons, including R-27 air-to-air missiles, range 50 miles, speed Mach 4, and R-73 missiles, range 19 miles, infrared guidance. The Su-27UB functioned not just as a trainer, but also as a heavy fighter in combat scenarios. The aircraft featured the N001 Mechek radar, with a detection range of 62 miles against fighter-sized targets, along with advanced fire control systems, enabling intercept and air combat missions. The plan was built on intelligence gathered from multiple sources. Commercial satellites provided high-resolution images of Armavir Airfield, revealing precise locations of hangars and air defense complexes. RQ-20 Puma unmanned reconnaissance drones with an operational range of 9 miles and flight time of 2 hours were used for supplemental nighttime imaging, leveraging infrared sensors to detect patrol activities. Additionally, insider sources in the Krasnodar region supplied details on the airfield's operational schedule, including times when air defenses lowered alert levels.
The Su-35 stands apart from many of its contemporaries.
Training at Armavir typically ran from 6 a.m. to 8 p.m., with pilots and ground crews resting at night, creating opportunities for surprise strikes. HUR determined that Armavir Airfield was protected by 2 Pantsir-S1 air defense systems with a maximum range of 12 miles, radar detection range of 22 miles, and 57 E-6E missiles reaching Mach 3. This system employed the 1RS-21E radar and optoelectronic sensors for target detection. Each Pantsir-S1 unit carried 12 57 E-6E missiles and 2 30mm 2A38M cannons, firing at 5,000 rounds per minute, capable of engaging both aerial and ground targets. However, analysis showed the Pantsir-S1 had vulnerabilities against small, low-flying threats like FPV UAVs, especially in poor weather or at night, when operators often reduced vigilance. This weakness was more pronounced in semi-automatic mode for the 1RS-21E radar, with reaction times 5 to 7 seconds slower than full automatic. The decision to use a homemade FPV UAV came after extensive discussions. This UAV was designed with a 3.9-foot wingspan, total weight of 11 pounds, top speed of 93 miles per hour, and operational range of 186 miles, powered by a 6S lithium-ion battery. Its 4.4-pound incendiary warhead, containing a thermite mixture, aluminum powder and iron oxide, could generate temperatures of 4,532 degrees Fahrenheit, sufficient to melt the aluminum-magnesium alloy skin of the Su-27UB. The control system used AES-256 encrypted signals, resistant to Russian electronic warfare systems like Krasuka-4, which could jam within a 186-mile radius. To enhance survivability, the UAV was programmed to fly at low altitudes below 328 feet, utilizing hilly terrain and valleys in Krasnodar Krai to mask radar signatures. The UAV also featured a backup inertial navigation system, INS, allowing it to maintain course even if GPS signals were disrupted for 15 minutes. Preparations lasted 4 weeks, with technicians testing the UAV at a firing range in central Ukraine. Tests included low-altitude flights, simulated electronic jamming, and warhead activation on mock targets. An electronic intelligence ELINT team deployed near the border to monitor radar emissions from Armavir Airfield. They found that Pantsir-S1 systems there often switch to semi-automatic mode at night, with crews reduced to 2 per unit for manpower conservation. This vulnerability prompted UHR to plan the strike around 1 a.m., when Russian air defenses were at their lowest alert. The ELINT team also noted intermittent nighttime radar scans from Pantsir-S1, with gaps up to 15 seconds between sweeps, creating ideal windows for UAV penetration. The FPV UAV was built in a secret workshop on the outskirts of a major Ukrainian city. Hidden in an abandoned industrial zone, the facility was equipped with industrial 3D printers, CNC laser cutters, and advanced circuit soldering gear. The engineering team's task was to produce a compact, low-cost UAV, powerful enough to breach Russian air defenses and destroy high-value targets like the Su-27UB. Each UAV cost about $2,000 to produce, a fraction compared to the $30 million damage it could inflict. The workshop operated 24/7, with 3 rotating shifts of 10 technicians each, ensuring 5 UAVs completed daily for contingency reserves. The UAV's airframe was made from composite carbon fiber, 0.08 inches thick, keeping the frame weight light at about 3.3 pounds, while rigid enough to withstand wind and vibrations on long flights. Minimal metal use also reduced radar reflectivity. The modular design allowed assembly in 4 hours and easy component swaps. A 1.2 kilowatt brushless electric motor was chosen for quiet operation, producing noise below 30 dB at 33 feet, nearly inaudible at night. The 6S lithium-ion battery powered 2-hour flights, maintaining 75 miles per hour in standard conditions. The motor was tested in temperatures from 14 degrees Fahrenheit to 104 degrees Fahrenheit to ensure reliable performance in harsh environments. The control system was the UAV's highlight. An ARM Cortex-M7 processor at 216 MHz, integrated with a GPS/NIS module, ensured positioning accuracy within 3 feet, even under GPS jamming. The 1080p FPV camera, with a 120-degree wide-angle lens and infrared sensor, delivered clear images in low light at 0.01 lux sensitivity. Camera data transmitted via a 5.8 GHz digital link using AES-256 encryption to resist interference. To reduce radar cross-section below 0.01 square meters, the UAV was coated in radar-absorbent paint from special composites, rendering it nearly invisible to Pantsir-S1's 1RS-21E radar. The system included basic machine learning algorithms, enabling automatic trajectory adjustments on detecting electronic jamming, boosting survivability by 20% over prior designs. The thermite warhead was central to the attack. The mixture, 70% aluminum powder and 30% iron oxide, was packed in a 4.4-pound heat-resistant steel casing. Upon activation, it ignited intensely, reaching 4,532 degrees F in 2 seconds, piercing the 0.2-inch aluminum-magnesium alloy skin of the Su-27UB. The electronic detonator triggered at a minimum 50 G impact, ensuring precise activation on contact. For testing, the team conducted 10 explosions on simulated metal plates, confirming fire spread within 5 seconds. Additional tests showed the reaction sustained for 10 seconds, ample to severely damage internal electronics and fuel systems. Fabrication took 12 days, with each UAV hand-assembled by a 6-technician team. Once complete, the UAV was tested at a central Ukraine range. Trials included 65-foot altitude flights, simulated Krasuka-4 jamming, and thermite strikes on mock targets. Results showed 96% accuracy hitting targets at 16 feet, even in 12-mile-per-hour winds. These tests refined control software for real-world stability. Simulations also covered adverse weather like light rain and fog, ensuring FPV camera image quality in all conditions. At 10 p.m. on July 25, at a secret launch site near an eastern Ukrainian city, HER's special team began deploying the UAV. This site, 174 miles from Armavir Airfield, was chosen as it lay outside Russian radar coverage in Donetsk and Luhansk regions. Outdoor temperature was 59 degrees Fahrenheit, with 80% cloud cover and light 6-mile-per-hour winds from the northeast, ideal for undetected UAV operations against optical or infrared sensors. The launch site was carefully camouflaged with thermal netting and radar-absorbent panels to evade Russian reconnaissance aircraft. The UAV was positioned on a mobile launch rail, a 110-pound steel frame with auxiliary boosters for takeoff assist. A Varan operator performed final checks on navigation and FPV camera. The control screen showed stable GPS, full battery, and normal camera function. The pre-programmed route divided into 3 phases. First, flying at 164 feet for 124 miles, using valleys and forests in western Krasnodar Krai for radar cover. Second, descending to 98 feet at 31 miles from target to avoid early warning radars. Final, dropping to 65 feet for the last 6 miles to prepare attack. The route was optimized via 3D terrain simulation software, drawing from satellite and drone data to identify low radar density areas. At 10:15 p.m., the UAV launched. The electric motor ran quietly, emitting a faint whine under 30 decibels. Base monitors displayed FPV footage. Expansive wheat fields, dim dirt roads in the dark, and faint lights from small towns. The UAV passed near a major city in Krasnodar Krai, home to a 3 GHz early warning radar station. Thanks to meticulous routing, it skirted radar coverage by hugging the ground, just 13 feet above treetops. To minimize detection, the UAV held 62 miles per hour in this phase, conserving battery for the final assault. In the first 30 minutes, it encountered 9-mile-per-hour headwinds, slightly reducing speed to 56 miles per hour, but autopilot adjusted motor power to compensate. Throughout the flight, the ELINT team monitored Russian electronic signals. At 11:30 p.m., they detected short radar sweeps from Armavir's Pantsir-S1 at 10-second intervals. However, no signs indicated UAV detection, thanks to its small radar signature and absorbent coating. As precaution, the operator rerouted through a dense forest near a major river in Krasnodar Krai. The rugged terrain, with low hills and thick canopy, shielded thermal and radar emissions. UAV signals remained stable, with 0.2-second video latency for precise control. The ELINT team also noted weak jamming from a Krasuka 4, 31 miles from the airfield, but AES-256 encryption prevented control disruptions. At 12:45 a.m. on July 26, the UAV approached within 6 miles of Armavir Airfield. This marked the mission's most perilous phase. The airfield was guarded by a dense air defense network, including 2 Pantsir-S1 units, each with 12 57E6 missiles and 2 30mm cannons firing 5,000 rounds per minute. Additionally, 3 Su-27UB anti-aircraft guns, with effective range of 1.6 miles and 2,000 rounds per minute, were positioned at strategic corners. Pantsir-S1's infrared sensors and 1 RS-21E radar could detect small targets at 3 miles in ideal conditions. But thick clouds and low flight reduced their effectiveness. Su-27UB guns were manned by night patrols, but due to manpower shortages, only one operated continuously, with the others activating on alert. The operator switched the UAV to manual control, using FPV camera for guidance. Footage showed faint airfield lights, where the Su-27UB sat in an open hangar. At 72 feet long, 48-foot wingspan, and gray camouflage, the Su-27UB was easily identifiable. The thermite warhead armed, with electronic fuse set to impact. The operator targeted the mid-fuselage, housing main electronics and part of the 20,723-pound JP-8 fuel tanks. FPV images also revealed a military truck moving near the hangar, but no infantry patrols, indicating lax ground security. At 12:50 a.m., the UAV initiated final assault. The operator accelerated to 93 miles per hour, diving from 65 feet. To penetrate defenses, it followed a zigzag path, shifting 15 degrees every 2 seconds over the last 1.9 miles. A Pantsir-S1 radar detected anomaly at 12:51 a.m., triggering alarm and switching one unit to automatic. However, the UAV's size and coating prevented lock-on. A burst of 30mm rounds from Pantsir-S1 lit the sky, but missed by at least 164 feet. Simultaneously, a nearby Zu-23-2 opened fire, unleashing 223mm rounds in 6 seconds. The barrage formed a dense fire grid, but the UAV's speed and erratic path slipped through gaps. In the final 10 seconds, a Pantsir-S1 optoelectronic sensor attempted infrared lock, but clouds and weak UAV heat signature foiled it. At 12:52:03 a.m., The UAV struck the Su-27UB's mid-fuselage, 6.6 feet from the left engine. The electronic fuse detonated the thermite, producing a small but intense explosion. The mixture burned at 4,532 degrees F, melting the 0.2-inch aluminum magnesium skin in 3 seconds. Flames spread rapidly, consuming electronics and fuel lines. At 12:52:10 a.m., a secondary explosion occurred as the Su-27UB's auxiliary tank, holding about 4,409 pounds of JP-8, ignited. This blast created a 49-foot fireball, shaking the hangar and scattering metal debris dozens of yards. FPV captured the final moment, blinding light, thick black smoke, and glittering fragments under airfield lights before signal loss. The explosion produced a 164-foot smoke plume visible from 3 miles, plunging Russian forces at the airfield into chaos for at least 15 minutes. The blast completely destroyed the Su-27UB, with mid-fuselage and engine bay incinerated. The steel and concrete hangar suffered major damage, with partial roof collapse and scorched internal equipment. Nearby ground vehicles, including a fuel truck and mobile radar, were damaged by debris and heat. HUR estimated the Su-27UB loss at $30 million, plus $2 million in infrastructure repairs. Airfield communications disrupted for 6 hours due to smoke and equipment damage. Training operations halted for 72 hours, affecting at least 20 pilot trainees. Damage included total loss of an auxiliary radar, reducing airspace monitoring by 30% for the next 48 hours. Russian forces quickly cordoned the site, deploying investigation teams and bolstering air patrols. Unofficial social media reports suggested Russia underestimated FPV UAV threats, increasingly effective in Ukraine's long-range strikes. This incident weakened training capabilities at the Krasnodar Air Defense Aviation School and sent a strong message: no southern Russian military base was safe from precise Ukrainian attacks. Initial Russian reports indicated deployment of 3 additional Pantsir-S1 units and 5 infantry patrols within 24 hours, reflecting concerns over follow-on strikes. The Armavir airfield strike marked a turning point in Ukraine's strategy, demonstrating precise intelligence, low-cost UAV tech, and bold planning. Using FPV UAVs with thermite warheads highlighted innovation against high-value targets on a budget. While Russia fielded advanced defenses like S-400 and Pantsir-S1, these proved ineffective against asymmetric threats like small UAVs. This gap, combined with reduced nighttime vigilance, was fully exploited by Ukraine. The operation underscored Ukraine's mass production of cheap UAVs, costing 1,000 times less than target value, pioneering economic warfare. Psychologically, destroying the Su-27UB struck a blow to Russian Air Force prestige, already eroded in the conflict. Krasnodar Krai, near Crimea and key bases, now emerged as a new UAV warfare front. For Ukraine, this victory bolstered tech confidence and potential for similar strikes. It challenged Russia to upgrade defenses against small, agile threats. Ukrainian media portrayed the attack as resilient symbolism, with articles stressing a $2,000 UAV defeated a $30 million fighter, boosting troop morale. In the darkness of July 26 night, A small UAV made history by destroying a symbol of Russian air power. From meticulous preparation, intricate fabrication, daring deployment, to dramatic strike, this operation exemplified modern warfare shifts. As smoke cleared over Armavir Airfield, questions lingered not just on material damage, but on Russia's response to Ukraine's increasingly sophisticated threats. In this war, technology, innovation, and persistence are reshaping the battlefield, turning seemingly invulnerable targets to ashes. The Armavir campaign was not just a military win, but a declaration that Ukraine could strike anywhere, anytime, with tools their enemy had yet to adapt to.